So, before we get into this topic today, one quick announcement. The link provided in the lab manual for the repository for today's lab activity is wrong and will be updated before your lab session today, so please keep in mind I'm aware of the problem. Essentially what was happening over the last couple of weeks is we decided to make an organization on GitHub that holds all the repositories instead of like them being held by my personal account, and I moved a bunch of the lab-related repositories into that, and that broke the links in the lab manual, and I told the Ryans to fix it, and it seems the Ryans haven't fixed it, so I have to do it myself. So that's just kind of how things go. Sometimes you ask someone to do something and then they don't, and then all the students get mad because the thing you asked them to do wasn't done. But anyway, don't worry. By the time your lab session starts today, the links will be fixed and you'll have access to all of the appropriate information to be able to perform the lab. Good. So, that being said, we're going to continue on with topic 5. We've covered the first section of it, roughly speaking, and we will continue on to talk about the rest in like fashion. So, let me just amplify. So, a question that was received immediately prior to the beginning of the recording of this lecture was, this seems an awful lot like how C goes about things. Certainly the concept of variables is one that we have normally in programming languages. I would just like to underline and underscore that bash scripting is not a programming language as we have conceptualized programming languages so far. This is not C code. If you try to compile this as C code, the C compiler will tell you you are being stupid because this is not C. Where's the main function, right? Although the same symbol is used for comments, it doesn't always mean comments. See the shebang. Right? Although in Python, these would be comment lines, that's not necessarily a comment line in bash scripting. So bash scripting is really just a way of collecting up a bunch of bash commands, putting them in a file, and being able to execute the commands in that file in sequence. There are a couple of bits and bobs thrown in, like loops and if statements, which we're going to study when we get to the sort of end of this presentation. But in general, every single line, with the possible exception of the first one, is a line that you could type into a bash prompt and it would perform the same function. In this way, it's similar to how with the Python interpreter, you can, if you want to, enter every line of a Python file into the Python interpreter one by one, and it would produce the same result. It's a similar idea here. The difference is that bash scripting is not a programming language. It is a meta language for organizing programs. So the sort of first class entities in bash scripting are full compiled programs that you may have written with C or any other number of languages, right? Echo is a program, not a function, right? So any program which we have executed in bash so far, CP, ls, grep, GCC, nano, although that probably you wouldn't put into a script necessarily, unless it were like an end case. All of these programs are the denizens of bash scripting. They are the things that live inside of the script. Bash scripting is a mechanism for automating tasks. You'll find as you're working in a command line interface that sometimes when you want to perform a particular operation, you will have a set of often repeated commands, right? In the same way that a set of often repeated instructions is best collected into a function inside of a programming language, a set of often repeated programs is best collected into a script file. Does that make sense? So, to recap, this is not C code. Effectively, you are learning two languages in this class. Two separate and distinct languages. And we're going to be focusing on C programming quite a bit more than bash scripting. Although, again, because bash scripting uses bash commands, anytime we're learning bash commands, we are effectively learning more about bash scripting. Does that make sense? Any questions about that? So let's recap how variables work. So bash scripting is different from C programming because you're not interested in numerical manipulation of integers and floating point numbers, etc. In bash scripting, what you're trying to do, the entire purpose of bash scripting, is to compose bash lines of invocation, right? You want to compose these commands which invoke programs. We have access to variables. Variables are an extremely powerful abstraction mechanism in bash, but they represent strings. You'll notice that unlike C, no data type has been declared with these variables. That's because all variables in bash represent strings. That's because these commands are composed of strings. And the only purpose of bash scripting is to compose commands. So there's no need for any other data type. At least at the surface level. You can get to that sort of thing if you sort of dig into things, but you know, for our purposes and at the moment, this is sufficient. So, the way that you declare a variable in bash, you simply type the name of the variable, you put an equal sign, and whatever the value you wish to assign to that variable is. Two things to note. Number one, note the absence of space characters. Inside of a bash environment, the space character carries semantic weight. So, this space here between echo and var1 does a lot of work. It is argument application. How many people here have studied Haskell programming? Right. So in Haskell programming, the space means application of an argument to a function. Right? In bash, it means something similar. It means the application of an argument to a program. So, the reason there is no space on either side of this equal sign, and the reason that it would be a mistake to put a space on either side of this equal sign, is because that space character would become part of either the variable name or the value. This is how bash thinks. Every character matters. There's no extraneous white space. In some ways, this makes programming in bash more difficult than programming in C. So, if I were to put a space right here between the equal sign and the hello, that means that the value of this variable would not be hello, it would be space hello, which has different meaning when it's substituted in substituted into commands, right? You would be inserting a space that you may not necessarily want to insert. Now, in some cases you may want it to insert that space, in which case you can include it in the variable name. But this is a common pitfall with respect to people who've only worked in proper programming languages before, in which you would include a space here because it looks pretty, right? In bash scripting is ugly because all of these characters that we use to format the thing and make it look nice and pretty will mess up the script. So bash scripts end up looking extremely ugly, but and difficult to interpret. But the whole point is that you only have to write it once, right? So, another thing to note about this: no quote characters, right? For roughly the same reason. The quote character already means something in bash. To include it inside of the variable itself would mean that the value of the variable would include the quote characters, which has an impact when it's substituted in. All variables are assumed to be strings from the outset. Therefore, it is not necessary for bash to distinguish strings from integers by use of quote characters. Everything is strings already, so quote characters are redundant and not used. Excuse me. Any questions about that? Okay. So, unlike variables in C, in order to access the value stored inside of a variable, you have to prepend that variable name with a $sign. The $sign says, I want to read this variable and substitute its value into the expression. That is the purpose of the $sign. If you do not include the $sign, the substitution will not be performed, and the bash command will just use the characters as provided as part of the command. So, for example, if I say var1 is equal to hello, var2 is equal to goodbye, echoing var1 says hello. Remember that echo is a program which simply prints out whatever its arguments are. It's like the bash equivalent of print, right? If, on the other hand, I perform the same command but leave out the $sign, it prints var1. The variable is only substituted for its value when you apply the $sign. Any questions? Cool. So what sort of things could be usefully considered variables? File names, right? You'll notice that a lot of bash commands are meant to operate on a particular file name, right? One possible use of bash variables is to store the file name that you're operating multiple commands on, right? And then substituting the file name in with all of these commands that you're executing over the file, right? Another possible use is if you're running the same command over a number of different files, like let's say, for example, you're compiling 10 C files, right? If you want, there are two ways of doing it, right? Let's say you wanted particular options enabled by using certain flags, right? Like W all to give you all warnings for these C files you're compiling, right? One way of doing it would be to write out all of the flags that you want to use each time you use GCC, right? Another way of doing that would be put the flags in a variable and then apply the variable to GCC in order to get the flags. That way, when modifying the flags that all of these compiler invocations are using, you only have to modify it in one place, which of course, that should be a drum I've been beating for you guys for quite some time. It's always more useful to only have to modify one part of something and get the effect than to modify every single place that something is used, right? This is modularity. This is component-oriented design. Good. So, do I have an example of this in a script? Yes. So we already did, last time in class we already did all of that inside of a script. So, good. So, in Bash scripting, quotes do not denote string values. Again, everything is already strings. So what do quotes do? Well, they do a couple of things actually. But if you want to include any white space, like a space character for instance, in something like a file name, you should include those quotes around the thing that contains spaces, right? So, touch is a command which creates files and also updates their timestamp to the current time. Also, touch can be used to update timestamps to times other than the current time, which is why timestamps are no proof of anything with respect to the time a file was last modified, which is why on-time submission is the only proof of on-time completion. It's actually very easy to use touch to sort of backdate a file modification tag. Very easy. So, for example, if I were to touch A, B, and C, A, B, and C are created as separate files inside of the directory. If, on the other hand, I put quotes around that, a file, A, B, C, with spaces is created. This shouldn't be rocking your world too hard. Yes?
Are the single quotes in that part of the name, or is that just like so we can tell that it's one file?
That is so you can tell that it's one file. So the ls program is inserting these quotes to minimize confusion. Another way of doing this is to use the escape character to escape the space. So this, let's say, RM, has the same effect as using quotes. However, it depends on how many spaces you have. It might be more efficient to just use the quotes. And this kind of looks ugly, but in general, it's a good rule of thumb, give me one second. It's a good rule of thumb when working in a Unix, Bash, or even a Windows environment to not use space characters inside of file or folder names for this reason. Some programs in Linux/Unix will even choke on files that have spaces in the name. LaTeX, for example, doesn't like it when you use particular characters in file names. LaTeX, by the way, is the program that was used to generate these slides. So, question?
Does it matter if you use double quotes or single quotes?
Yes, they have slightly different meanings. I think, if I recall correctly, it has to do with whether or not variables are expanded. Yeah, so single quotes will block the expansion of variables. Double quotes will not. So that's the difference, yeah. Otherwise, though, like there might be a few other, like, shall we say, more esoteric differences between the two, but at our level of understanding that's sufficient. That's sort of a general characteristic of bash scripting in Linux/Unix environments is like, there's a whole lot of stuff going on that like we would never be able to cover in the context of like this one course, right? Like each one of these commands that we're using, it would be impossible to cover them exhaustively because we would require like half the semester just to cover something like grep, right? So that is why the important skill which you are supposed to be deriving from this class is the ability to read the friggin' manual and find the information that's relevant to the task that you want to perform. I'm trying to give you enough of a basis in these technologies that you're not completely lost by them. You sort of are conversant in bash scripting, you know what one is supposed to look like. But I cannot exhaustively teach you all of these commands because there are literally thousands of them and each one has hundreds of modes, right? So you have to gain the ability to find the mode which applies to your situation. Becoming good at Linux is something that has such a high skill cap. You can literally spend your entire life becoming better at Linux. But the question is, can you learn Linux faster than Linux is being developed? And the answer is probably not. So, although some people give it a run for its money. But anyway, good. Oh, that was actually my next slide. So, single versus double quotes. Single quotes preserve the input verbatim. This is useful for certain commands like grep, where the input parameters use symbols which overlap with symbols used in bash. So sometimes you will want symbols that have other meanings in bash. For example, the $ character expands variables. You don't always want it to expand variables. Sometimes you want bash to use that character verbatim. Another good example would be the octothorpe hashtag character denotes a comment, but if enclosed in single quotes, it does not. It's just a hashtag character, right? Good. So double quotes preserve input, but also permit substitution. So double quotes allow some variable substitutions to be made, which is, fairly useful. Any questions? Good. So, the following special variables are reserved for managing the arguments to your bash script. We know that programs may accept arguments. Bash scripts themselves may also accept arguments. So you might be asking yourself with respect to this this example that I was giving you, where we want to perform a series of commands over some particular file name. One way to get that file name into the script would be to hard code it in the script itself. This is obviously less desirable from, we try to avoid hard coding things whenever we can, right? It's considered, the hard coding values is the last refuge of the inferior programmer. So, rather, you write the script in such a manner that it accepts arguments, so that the script can be run with any number of file names. You provide the file name to the script using an argument. So, numbers 1 through 9 are the first 9 supplied arguments. The @ symbol, all supplied arguments, and the number sign, /hashtag, /octothorpe, # symbol, whatever you want to call it, the number of arguments which have been supplied. So, let's examine the operation of this script, which includes an if statement, and we haven't gotten to if statements yet. That's in conditionals, but it's still kind of interesting, perhaps. So, we have this bash script. We test to see if the value of the number of arguments supplied is equal to, -eq means test of equality, to, then echo the value of 1, echo the value of 2, otherwise echo incorrect number of inputs, end if statement. Bash has this interesting thing where if statements are ended with if backwards. Just in case this wasn't complicated enough for you. So let's do that then. Just to see how this works. Now, what are we going to call this? Inputs.sh. So, first step, of course, is the shebang. We want to run this with bin/bash. If number of arguments is equal to, then echo 1, echo 2, else. Okay, so Nano is doing a very useful thing for me right here, which I think is useful enough to actually recommend it to you, to all of you people for your use. It's highlighting everywhere where I've got a space, right? The thing about spaces is you can't see them, right? But if the editor itself is telling you where you've got space that's not being used, and you go in and delete it, then you're writing correct bash scripts. So use Nano for bash scripts. That's what I'm telling you right now. So echo incorrect number of inputs or arguments. Fi. Save modified buffer. Yes, save. All right. Can't run it yet. Why can't I run the script yet? Anybody? Yes? You have to make it executable. Yes, excellent, thank you. chmod +x inputs.sh, there we go. Turns it green, and now we can execute it. So inputs.sh. Incorrect number of arguments, because I have provided none. A, still incorrect. AB prints out AB. ABC, incorrect number of arguments. Make sense? Any questions? Good. don't worry, we're going to talk about if statements. We're going to talk about what the heck this conditional means. One very important point, if you're looking up like Stack Exchange or any of these types of websites for examples of how to do a particular thing in bash scripting, heck, if you're copying it off these slides, very important that not a single character is out of place, right? The spaces are important. It doesn't seem like it, but the fact that there's a space right here is important. These spaces are important. This semicolon is important. Without any of these, the bash script doesn't work. The fact that these are square braces and not round braces is important, and otherwise the bash script won't work. Make sense? You have to be exact to the character. In Python, you can be very loose. In C, you must be more exact. In Bash, you must be more exact even than in C programming. Good. So, you can provide arguments to a bash script the same way you provide arguments to any other bash script. Incidentally, one of the other things you can make variables is the names of other programs. So you can say, like, you know, if you have a C program and several C compilers installed, you can provide as an argument the name of the compiler that you want to compile the C program, and so long as you're putting it in the correct position inside of the bash command, it'll work. Just to, hammer the point home. For example, if I were to let's say I wanted something like that, right? Then inputs.sh, do I have a C file in here? Not really, okay. It doesn't matter. GCC file. Undefined reference to main. That is an error that C receives, or GCC, it's an error that GCC gives you when you give it a function, like a file that does not contain a main function. Since this file is empty, it does not contain a main function, and therefore it's not a valid C file. But that's not the point. The point is, I specified a program as an argument. Just giving a moment to let that sink in. So you begin to see the power of this. Scripts can be arguments to other scripts. Scripts can be executed by other scripts. Like the whole of Linux is a series of programs and scripts which are all invoking each other. That's all it is. That's the entirety of the operating system. There's no magic in it. It's just programs and scripts. Okay? I have a 15-month-old at home, and he has like an abject fascination with cell phones, as a lot of small children do, and frankly a lot of adults and regular-sized children do. And I often comment to my wife, "Oh look, he's taking a look at the magic rectangle again." A lot of people like think of this technology as being magic, right? Like conceptually, they don't really think of it as technology. It's just, magical, You provide it, magic points in the form of electricity and it performs tasks for you. You know, it's like, effectively to most people, there's no difference between like using a cell phone to call someone and like a telepathy spell in like an RPG or a tabletop RPG, you know? But I have to break you guys of this way of thinking. Everything with respect to all of these modern conveniences is explicable in terms of electronic physics and the organization of commands. All of it, right? There's no magic here. This is not a class on magic. If you want a class on magic, go study classics or something. Anyway, so here are some more special variables which you should be aware of. 0 is the name of the bash script. You may notice that this is the completion of the numerical series which we used to acquire inputs from the script, right? In bash, the program's name is the first argument. It's argument 0. That's how it works. If you do $, that gives you the process ID of the currently running script. $user is the username of the user executing the script. Hostname of the machine running the script. Random produces a random number. Home is the home path of the user executing the script. This is actually more useful than you might think. Of all of these, this is probably the most useful in this list. What this does is it allows you to address file paths relative to your home directory. And path contains all of the directories at which bash can find your binary executables. So you may ask yourself, how is it that bash knows all of these programs and where to find them, right? It's not baked into bash. There is an environment variable that tells bash where all of the programs are stored. And you, the user, can modify the path variable to add more directories. So, if you are, for example, installing a program, one of the steps that you use if you want that program to be callable as any other program would be in the bash environment is to update the path variable to include the directory that you installed it in. By including that directory where the binary for your new program is found, bash will be able to find it and call it as any other program. Make sense? Again, not magic. The computer knows like what it's doing, you know, because it has these variables. There are actually quite a few. There are quite a few of these types of variables, which are called environment variables, and they all have special functions within the bash environment. And by modifying the environment variables, you take control over bash. You can configure the bash environment. So, just as an example, home is home/nick, because it is. Path. These are all of the folders which I have, which are looked in for executables. You'll notice that I, in fact, myself have modified bash so that a program called PVS, which I used for my thesis work, can be called directly from the bash prompt without need to know where the folder is. Incidentally, in these types of lists of arguments, the colon character is used to separate individual paths. So, What do we not include in file names or folder names?
Spaces.
Spaces and colon characters, right? Because if you include a colon character in a folder name, then, like, for example, if we want, how would the computer tell the difference between looking in, bin and then user/games or bin : user/games, right? How would it be able to tell the difference? It wouldn't. Don't include colon characters in folder names. Don't include anything other than like alphanumeric characters and underscore. And dot. Dot is also okay because it's used for file extensions. Don't use commas, don't use vertical bars, don't use semicolons, don't use colons. Just use normal characters. Anyway, there are a bunch of other ones too. PWD is actually kind of a useful one. That gives you your present working directory. So this is where I currently am, right? But yeah. So all of these things are maintained by bash session. When I cd to a different folder, bash automatically updates the value of this variable to reflect my new position in the file hierarchy. Make sense? Question?
So when you call the program PWD, does it just echo that variable?
Yeah. Yeah. PWD does the same thing. Yeah, it just echoes that variable without the is a directory bit. But let me ask you a question. Of the two of these, which can be substituted directly into another command?
Could be either.
It's this one, right? So this, for that purpose, that's more useful. Now, it is possible to take this value, feed it into another command. We're going to, at the end of this course, we're going to talk about pipes and filters. You can pipe that to another program. Like, for example, echo home pipe to ls. Well, that actually didn't work. All right. Well, at any rate, you can just do ls home anyway. If you specify a directory, then ls will show you the contents of that directory. In the absence of any specified directory, it will insert this one, which is the current working directory. That's how it knows where to look. It's because it keeps a variable. Ha! So, anyway. So you might say to yourself, okay, so this sounds interesting. Given that updating the path variable is an essential component of manual installation in Linux environments, it would be nice to know how to do so. This is how you do so. The bash environment has a couple of startup scripts. It'll depend slightly on the particular distribution of Linux that you use, but this is the essential way that you go about it. So, a common part of manual installation in Linux requires setting environment variables for the program you're installing. To do that, we need to access Bash's startup routines. By the way, you should be thanking me for having this slide because your dear old professor had to figure out all of this out with no help whatsoever. Of course, I never took a course like 1xc3. When bash starts up, it begins by looking for the script in /etc/profile and executing it if that exists. So this is the sequence of things that happen when a new bash session is started, right? Changes here affect all users and require super user privileges because you should all remember from your lab last week, etc. is it's a system file. It's a system folder, right? It's in the operating system. It's not in your user space. So you need sudo permissions in order to modify things in there, right? So, fine. The next place bash looks for, depends on whether or not the shell is a login shell. If you entered a password, you're in a login shell. In a non-login shell, it will run .bashrc if the file exists. In a login file, it looks for .bash profile. Notice the dots. These are hidden files, right? Hidden files, and the little tilde means home directory. So, hidden files in your home directory. Bash profile, bash login, or .profile in that order, and executes the first one that finds that works. In both cases, changes do not affect other users, and super user privileges are not required to make the modifications. So, for example, in my home directory, list all. You can see I've got lots of hidden stuff, including a hidden folder for Minecraft, which I have only played a couple of times on this, and never, like only ever to like test the system, test its abilities. But anyway. So we are looking for .bashrc. There we go. So this is the contents of my login script. You can see that it's got a lot of stuff in here that is like perhaps not particularly interesting. However, a modification which I have made here is the export command takes a variable and pops it up to the next level, right? So when you create a variable in bash, that variable is bound to the script which it is executing it, right? However, you can think of your bash terminal itself as a running script environment. So in order for a variable which has been declared inside of a script to be visible outside of that script, you have to export it. It's basically, it's similar to the idea of declaring it as a global variable, right? So anyway, path is already in the exterior environment, so it doesn't require export. Path is equal to path with all of this stuff added on the end. I know it's, again, that terrible red on black problem, but that's path right there, right? So path is modified inside of my script because I wanted to add the executable at this directory to path. Make sense? So that's how you modify your startup script to modify environment variables. Most of them you don't want to touch, right? There's no reason to modify home, for example, and you'll just mess up everything that relies on home, which is most everything. So, like lots of the variables, it's unwise to do anything to them, but you know, some of them, it can be useful to do something to them. Does that make sense? It's like, look but don't touch. And it doesn't tell you what things you should and shouldn't touch. You should just use your brain and figure it out. Like, you know, like, be cautious when you're modifying variables. But, yeah. This is like another one of these ways that you can easily screw up your computer in such a manner that it's irrecoverable. Good. So, in order to set environment variables, all we need to do is add them to one of Bash's startup scripts. We already know how to assign variables in Bash script. Variables assigned in this way are scoped to the Bash shell that created them, but are not transferred. If you put the export command in front, then this makes the variable accessible to the creating Bash session as well as all sub-processes. So other Bash scripts which your Bash session executes will also be able to see the variables that you set with export, right? It's like, so if you imagine, this is your global Bash session that you've started, right? The first thing it does is it runs startup, right? Let's say you are wanting to export, you're wanting to create a variable A, right? So you create, A is equal to hello, right? And the variables that are in your running Bash session are, things like home, things like PWD, right? Because they're in this superordinate Bash session, home and PWD are shared by all of the things that this session creates, right? So if it started another session called MyScript, it would take these guys as well, and they would be available in MyScript, right? What the export, oh wow, I lost one of those little tabs already. What the export command does is it takes A and promotes it to the level above. So now, when this guy runs another script, it's grabbing all of this, including this one that was exported. Does that make sense? Any questions? Okay. As you can hear, I'm not quite over that cold yet, but So, example, extending Bash. Recall that Bash uses the path variable to look for executable programs. If you are adding a new program and you don't want to have to navigate it to the folder in order to run it, add it to path. Add the above line to Bash profile or similar. This guy right here. You actually don't have to export it, but that's okay. Calling echo will show the different path looks for in a colon separated list. So notice, when we are adding to path, and this is very important because this is how variables work, $path expands path. We put on the end of it colon and then the path we want to add. Reassign that back to path. That extends the definition of path with the new path, right? If you didn't include this bit, you would overwrite path to be just this directory. So you could actually seriously damage your computer by not including this bit right here. Because if you set it in your startup routine that path is overwritten by just some directory, you would lose the ability to call all programs that were indicated by the rest of path, right? At least to invoke them directly. You would still be able to get at them if you knew that program's absolute address inside of the operating system. So, you wouldn't be able to use ls you wouldn't be able to use CD, right? You would have to go /bin/ls or /bin/cd, depending on which folder ls and cd are actually contained in, right? Because you lose path. That's what the effect of path is that you don't have to know what folder the executable is in. Make sense? Okay. So. This construction is similar to Python's += operator. Any executable binaries at the specified directory can be used as commands. The only catch is that you have to restart your bash session so that the change takes effect. So if you modify your startup script is only executed when the shell starts up. So in order to see the effect, you have to close your current session and restart it so that the startup script is running. Make sense? Any questions?
Can you make an example?
Can I give you an example of what?
The export path equals, never mind.
I did, but I can again if you like. So, sure. Hello, right? So I've got hello, right? Simple program that we wrote earlier in the course. Let's say I want to be able to call this program from anywhere, right? What is my current working directory? There we go. So, if I want to add this to path, right? And I'm not going to do it inside of my startup script. I'm just going to do it locally inside the session. Path is equal to path : current working directory. You'll see that to the end of path I have added home/nic/teaching/1xe3 summer 2022 examples topic 3. Right? So now, if I go to my home directory, for example, I can run that hello program. Does that make sense? Question?
Well, what would you have to restart? I thought you said you'd have to restart.
Only if you're modifying the startup script,
Okay.
right? In this case, I haven't modified the startup script. What I did was I simply modified path within this currently running bash session. When I close this window, this modified version of path disappears, right? If you take this line, or some equivalent of it, place it inside of the startup script, which all of your bash sessions execute as the first thing they do, then that change is globally applied to all bash sessions, right? But in this context, this is good enough to demonstrate how path works, if that makes sense, right? Cool. Any other questions? These are good questions. Okay. Julio. So, let's take a deep breath. Because that's a lot of information. You guys get the joke? Meanwhile, at Linus Torvalds' house. You guys remember who Linus Torvalds was? The guy who invented Windows? I mean, not Windows, Linux.
Yeah.
Bill Gates was Windows. Notice what this house doesn't have?
Windows.
There you go. To be a nemesis, you have to actively try to destroy something, don't you? Really, I'm not out to destroy Microsoft. That will just be a completely unintentional side effect. So, Linus Torvalds was at one point quoted as saying that when Windows supports a bash prompt, he will have won. What did they add in Windows 10 again? Bash prompt, yeah. So, Linus thinks he's won the fight because, Windows is being forced to be less terrible. So, we're trying to take Windows and drag them kicking and screaming into the age of the Enlightened. But, unfortunately, Windows and their fat corporate contracts are, money does have a certain amount of influence over good design, unfortunately. Windows is terribly designed. I'm going to stop complaining about Windows more. We're going to talk about slides again. Anyway, so, Windows is terrible. DOS, Disk Operating System, is Windows, the old Windows equivalent of the bash prompt. They made the slashes for folders go the other way for no reason other than to be different from Unix. That's the only reason they used the wrong slash. They're stupid. Anyway. So, just to beat this a little more firmly into those brains of yours, beware of white space. White space, that is to say, spaces, tabs, and new lines, have more semantic content in Bash than in any other language with the possible exception of Haskell. Think about the way commands are structured. A space denotes argument application. Bash takes every character literally. So, this is good, this is evil. Be good, not evil. Bash also has no types. Any programmer not utterly ruined by Python knows that variables have types. So, in C, this is an integer, this is a string, this is a character, right? In C, strings are character arrays. In Bash, however, this is some text, this is some text, this is some text. Everything is strings. It is more correct to think of variables in Bash as being more like macros in C than variables, in that they perform direct character substitution, regardless of syntactic construction. So, all it's doing is character substitution. When we study macros in C, you will see that C, the programming language, also has the ability to perform direct character substitution. You can have so what a macro does in C, you can actually have macros insert things like function declarations or multiple curly braces or other things which would otherwise be considered parts of the language C, right? Things without which the program wouldn't be a valid C program. But that's because in C, you can perform character substitutions using macros. This is closer to the idea of character substitution than it is to the idea of variables as you know them. So, to some degree, calling these variables is a misnomer. To some degree, we should be calling them macros, but the literature calls them variables, so we need to get used to the idea that these are called variables. Make sense? Any questions? Good. So, concatenation. Because of this, concatenating does not require an operator. Because everything is just direct character substitution, if you perform two character substitutions adjacent to each other, they'll just substitute. So, in Python, we would do something like var1 is equal to hello world, hello plus world. In Bash, we just perform adjacent character substitutions. So, for example, echo, let's see, what do we got here? No, this is the wrong one. There we go. Hello, goodbye. That's how you concatenate things in Bash. And that's like, you know, a thing that you will, a thing that you will often want to do. So, command substitution. If you want to assign a variable to the output of a command, you need to use what's called command substitution. So, we use the $sign again, but then we have round braces bracketing another command. What this does is it captures the output of that command and stores it in the variable. So, for example, LSL lists all of the files in the current working directory. Rep v total counts something, and then word count counts something else. We'll see when we break it down in terms of its individual commands. So let me see here we go. So LSL, there we go. So that's all of the visible files in the folder. Rep v total gives you, let's see here. I'm not sure what that's doing, to be honest. Seems like it's removing quotes. All right. I know what word count does, though. Word count counts the number of lines when given this argument. So we got 23 files. Still expressed as a string, by the way. Actually, can we get rid of the grep? Can we just get rid of that? Would it still have the same effect? Oh, okay. So it's removing this line at the top. Okay, that's fair. And if we want to do all of that, including hidden folders, files and folders, I've got more like 90. So if we have the results of this operation and we want to store them to a variable, count is equal to, count being a new variable, all of that enclosed in around braces. Then we can echo count, and the value of the count variable is this value of this operation as given previously. Any questions? So, for example, perhaps you are writing a script where you want to navigate the file structure somewhat and then return back to the folder which you originated in. One thing that you might want to do is capture the results of the pwd command, which prints the working directory. So, return to, and again, there are different ways of doing this, but, there are different ways of doing a lot of things. Then you can do all of your stuff, and then at the end, so long as you cd back to, return to, that would bring you back where you were. I suppose I should actually go somewhere. cd teaching /1xc3. Sure. I'm now in a different folder. cd return to brings me back where I was. Right? So positions within the file system are things which are usefully stored in variables as well. Any questions? If you understand how bash scripting works, you understand how bash works. It's like bash and bash scripting are really the same thing. Cool. Incidentally, this is also your rough introduction to pipelining. So these vertical bar characters indicate that I am taking whatever this command is routing to standard output and redirecting it to the standard input of the next function, or the next command. So ls prints out a list of the current files in the directory. That becomes the input of grep without being printed. It's redirected, right? And then the output of grep is redirected to the word count function, right? Or command, pardon me. So that's, you can direct the output of one program to the input of another. You can save the output of a command in a file. You can take a file and make that the input of a command. Like you can route a file into standard input. Like you can, the things you can do are manifold. Yeah. So let's talk about subshells. This is a visual pun. Code executed inside of a script is considered to be a subshell of the shell that it's executed from. This is this same topic that I've been talking about on the board. Variables within a shell are not automatically available within the shell. Subshells spawned by a shell. Think of it like global variables in Python. To use them within a function, you have to declare them. So you use the export command to accomplish this, as I've kind of already talked about at length. So, you may be asking yourself, okay, sure, but what about math? I am a computer scientist, gosh darn it. I want to be able to perform arithmetic. Well, it turns out there's a command for that. Integer arithmetic must be performed within the double parenthesis environment. So similar to variable capture, but you use 2 parentheses instead of 1. This is actually syntactic sugar for another command which performs arithmetic expressions. XPR, EXPR, expr. So yeah, you put math in here and it will calculate, 2 plus 2 equals 4. You can then store that in variables. Both of these accomplish the same thing. So, for example, expr 2 plus 2 is 4. Truth is equal to 2 plus 2. Did I get it correct? 4. Any questions? Incidentally, I'm pretty sure that you can then perform commands like this. Yeah. So variables can also be used in these expressions. Now, it's very important to realize what this command is doing is it's interpreting string inputs as integers. This does not change the universal fact that variables in Bash, store everything as strings. This has not changed. The expression command simply knows how to deal with that. Any questions? You have half a question?
I'm trying to organize my question. Is it possible that the recursion happens?
Recursion, eh?
If you give the truth an initial value, then truth equals truth plus.
Well, this won't be. You won't get to recursion here, right? Because this works the same as like a plus equals operation, which is not recursion. It's like x equals x plus 4. It's like new value is calculated and then assigned to x. So not recursion. However, I don't think I've actually tested it, but I don't think there would be anything preventing you from executing a script within the same script, which would be recursion. I don't know why you would need to, but generally speaking, when we say a command in Bash is operating recursively, we mean recursively over the system file structure, right? So, like the difference between RM and RM recursive, RM will only remove files in the current directory. RM recursive will remove directories and everything they contain recursively. So the idea of doing something and then doing the same on subfolders and doing the same on subfolders, that's what we consider recursion inside of a Bash environment. Make sense? It's recursive on the tree structure of the file system itself. Yeah? Any questions? Okie dokie. So let's talk about conditionals. Let me just like that. So, in general, if statements work more or less the same way that you would expect them to work in any other programming language. You supply a condition. If that condition is true, you execute the first branch. Otherwise, you either test or execute subsequent branches, depending on whether they are if or else branches. Notice that the nomenclature in Python has been borrowed from Bash scripting. Remember that Bash scripting predates Python. So, the trick, of course, is how do we write conditionals, right? So, in the same way that the expression command evaluates arithmetic expressions, the test command evaluates expressions which result in booleans, right? So, test is implicit in the fact of square braces being used. This is actually not necessary. You can use test directly, but this is less writing and looks nicer. So, a full listing of the sorts of tests you can perform is in the test man page. I've shown you guys man pages, right? Good. Let's take a look at the man page for test. The main man page for expression is also interesting. So, test. So, check file types and compare values. So, expression is true. You say that with by enclosing it in round braces. Not expression is false. It has the bang character in front. Dash A between expression 1 and expression 2 indicates Boolean and. O, Boolean or. N, the length of the string is non-zero. So in this case, the string provided is non-zero. So this N flag would always give you the true branch, right? Z, the length of the string is 0. Equal sign is equality. Bang equals is not equal. EQ is a test of integer equality as opposed to string equality. Very important distinction. And you can see there are a large number of these, including things like testing to see if file exists, testing to see if files exists and is a directory, which are important things to be able to test if your variables are primarily file paths, right? So, like, for example, using this, it would be relatively simple to write a script that creates a file if it doesn't already exist, you know? If file exists, do nothing, otherwise touch file, right? Makes sense, hopefully. If we take a look at expression, you can see that we get a whole bunch of operations for expressions as well, including regular expressions, which we'll talk about later on in the course. So, any questions about any of that? Yes?
I'm sorry, what's the meaning of the N?
What's the meaning of which?
The N before the hello.
That is a particular flag which indicates the type of test which we are performing, right? If you look it up in the test man page, N means we are testing this to see that the provided argument contains more than 0 characters. So, this is, hello is just a string literal, right? Obviously it contains more than 0 characters, so this test will always come out true, right? And we echo, hello is bigger than 0. We could easily also, like, extract hello, make it into a variable, you know, and have an else branch, right? Make sense? To some degree? If you guys have any questions, please. Yes?
What is FI?
FI ends an if statement. So in the same way that in C, you would have a curly brace here and an end curly brace there, in bash scripting you have then and fit. Any other questions? None whatsoever? Everyone's going to get perfect on the exam then?
No.
Still confused.
Still confused? What is the source of your
What's the
confusion?
meaning of
What is the meaning of which?
the n? So does it mean like always true? Or
So, let me show you. Test n, hello. No. How do I get it to show the goods? I think I'm just gonna have to write the script. Alright. So, if n, hello, then echo hello is bigger than 0. Say characters were found, else echo variable is empty. And if I just substitute this for, say, argument 1, end it with an fi, there we go. Make it executable. There we go. sh, and say 1, 2, 3, 4. Characters were found. Characters were still found. Interesting. No such file or directory. Interesting. Well, what characters are they then? That's interesting. It says it's blank. Strange. At any rate, I'm not sure why that's not working. But n is just a particular type of test which you can perform, right? So, for example, I could easily modify this so that say I wanted to test to see if, inputs 1 and 2 are the same. Echo, oh gosh. Inputs are the same. Inputs are different. Inputs are different. Inputs are the same. Right? If I want to, do that example that I was talking about, right? copy conditionals to const2.sh. Now const2.sh. There we go. This is just a copy. Let's say if this thing exists, remember that -e tests to see if a file or folder exists, returns true. If this thing exists, false otherwise, right? Then echo file already exists. Otherwise, okay, I'll make that file for you. Touch argument 1, echo, have a nice day. So, then executing const2.sh on something for example D. Okay, I'll make that file for you. Have a nice day. You see that it made the file D. Otherwise, if it's a file that already exists, like say maybe itself, file already exists. Sometimes, like, you may want to create a file and then give it some contents. You know, copy contents in from some other location, for example. That's what these conditionals do. Does that make things any clearer? Yeah? How about the rest of you? Any questions? Okay. Good. So, I have a LaTeX problem in this slide. So, this is a non-exhaustive list of the comparisons available in test. For example, string equality, string inequality, integer equality greater than less than, see if an item exists, see if the thing exists and is a file, see if the thing exists and is a directory, see if it exists and is executable. All of these different types of tests. Again, you kind of just have to understand that you can test 4 different things. Memorizing all of these tags is not useful, or not as useful as knowing where to look them up in the man pages. Right? Man test will give you the full list. Make sense? Good. So, in addition to conditionals, we also have loops available for us. We're still recording?
Yes.
Cool, good, thank you. So, there are a couple of different types of loops that you can use. Perhaps the most basic is the regular while loop. So you have, for example, a count variable. While count is less than 10, do the contents, echo count, then count is equal to the evaluation of the expression count plus 1. Done. This will print out the numbers between 1 and 10. Let me just demonstrate. So, now while script sh count is equal to, or I'll just call it C, is equal to 0. Bash variables are normally capitalized by convention, but it's not necessary. While square braces, so we know we're doing a test. Count, or C, is less than 10. Do echo count. Again, why do I ever depart from the slides? It'd be nice if I could remember anything I'm currently doing. There we go. In the same way that fi ends an if statement, done ends a loop. Let me just is that a little bit better? Even a marginally better is better in this circumstance. So, fine, good. Save. We chmod plus add executable permissions to while scripts.sh. Oh, by the way, if I haven't mentioned this yet, when you're typing a file name, pressing tab in a bash environment will autocomplete a file name up to the point where that file is unambiguously able to be auto-completed. So tab is your friend. So there we go. We then execute while script, and it prints out the numbers between 0 and 9. There we go. Any questions? Yes?
Okay, I know you said spaces are like really important, including the spaces inside the brackets, like those two on either end, like we have to make sure we have them as well.
Well, we can test it to see if that is necessary. Generally, again, it's like, I don't want to give you permission to do it because like there are instances where like it does matter. I'm not sure if this is one of those particular ones, but it's like. Let's take a look. So in this case, it seems to work. And in that case, it doesn't.
Okay.
So given that sometimes it works and sometimes it doesn't, you don't have to memorize which cases it works in and which cases it doesn't. Just put a space always, and that'll be good enough. Any other questions?
I have another question.
Yes.
Oh no, I forgot. Oh yeah. Sorry, I know you said this before, but what exactly does the chmod do? Is it like compiling it?
No. All it does is it adds executable permission.
Okay.
So normally, plain text files are not, you can't just run them as a series of commands, right? You have to modify the permissions of the file inside of the file system in order for it to be something valid to be run. That's what the chmod command does. Plus X adds executable permission to whichever file is specified. We actually have a couple of slides on this in a previous lecture, if you'd like to go back and take a look at more extended usage. But yeah, that's necessary because otherwise we wouldn't be able to run the file, right? And recall that inside of the bash script, actually I think I forgot to include the shebang, didn't I? It probably defaults to bash, which is fine. Yeah, if you include a shebang at the top, then you can specify the program that you're using for a shell. And then when it executes it, it'll read that first line, look up whatever program you've specified, run this file using that program. And if no program is specified, it'll just use the one it's currently using. Okay, so, good. So that's while loops being the easiest and most direct way of performing the task. You can also have C-style for loops. So, for double parenthesis, I equals 0, I is less than 10, I plus plus, do, echo, I, done. And run that bad boy. 0 command not found. Oh, I still got an error in it. There we go. So you'll notice that now we are counting from 0 to 9 twice, right? You should notice that the syntax for this looks shockingly similar to the syntax for a for loop in C. The one major exception being lack of a type declaration here. Again, I is still string, right? It's just being read by the various programs operating on it. What this does is it uses a bunch of these programs behind the counter so that you can like fool yourself into thinking you're programming mildly in C for a moment. Make sense? Of the 3 different styles here, this would be the one I prefer personally. But for loops do something a little bit different. So a for loop should have called it loop script. Anyway. If we have some value of a variable that has spaces in it, remember how important spaces are, right? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Remember that the outputs of various programs will give you things like this, right? For item in input, do echo item, done. And you can see it outputs all of these things, right? So that last one is kind of interesting. You could do something like, let's see here. I just want to show you something. What's not on my last? Yeah, okay. Okay, I'll cover this last slide and then I'll show you something interesting that you can do with for loops. So, internal field separation. By default, Bash separates inputs and arguments by white space. However, if you set the if-s variable, then you can change what it splits on, right? So you set it with a particular value, then you set it, then you can unset that variable Incidentally, you can use the unset command to remove variables which have been set from your environment. So this is a special variable which is looked for by for to specify the character that things are split on. So you can imagine that when path is being read by the bash environment, it is splitting on colons rather than on spaces, right? And once you unset it, it returns to doing things by space. But yeah. Does that make sense? I'm going to do an example. So, let's take a look. Not folder. Jeez. Let's say ls, right? Let's say that input is the result of ls, right? For item and input echo item, right? Let's comment out the rest of this for now. So you can see that the variable item has been mapped to every file name in the current folder. So let's say, just for the sake of interest, we wanted to create a backup of all of these files. Which is, you know, something that you might reasonably want to do. Make directory, backup. For each of these items, copy from input, from item into backup/item. Save, close. Execute. Oh, omitting directory backup. No such problem. R not specified. Let's see here. I'm getting my usage wrong. Let's see. Slash backup maybe? Include the R flag, as it asked me to. Well, the backup folder does exist. What am I doing wrong here? Copies from source to destination or multiple sources. Have I got it just the wrong way around? Source to destination. That should be fine. What does the R flag even do? Recursive copies directories. Oh, that will fail to expand the quotes, or expand the variable. Oh, I know what I'm doing wrong. Ha! I know what I'm doing wrong. It's not backup slash item. It's just backup. It doesn't want like the new, I'm confusing it with move. In move, the move command, you specify the new file name that you want. But with copy, you just specify the folder that you want it copied into. So this should work. Let's take a look. Cannot copy a backup into itself. Yeah, that makes sense. So you could. So let's take a look in backup, see if it worked. Ta-da! Copied all of my files into backup, regardless of what those files were. Perform some operation over all files in a directory. That is what this script will do, depending on what this operation is. Does that make sense? I would just like to underscore, before I let you guys go, how incredibly powerful this stuff is, right? All of this pointless middle management busy work that you do with files and folders can be automated and can be intelligently automated. Yeah. Thank you for your time and attention.